Okay, this animation shows the essence of the Michelson-Morley experiment. So think of the white background here as the ether, and then we have the interferometer attached to the Earth. The Earth is moving through the ether. Okay, now on the left-hand side, let's assume that the Earth is not moving with respect to the ether. So then therefore we have the two light beams leave the light source, which is right here. The two beams then hit the beam splitter, which is right here, sending then the two beams of light along their respective paths. And then if the Earth is not moving with respect to the ether, you can then see that the two light beams arrive back at this point right here at the same time. So then therefore they are in phase. They would then constructively interfere with each other, and that would then produce a bright interference fringe. The actual interference pattern itself, by the way, is formed by taking the two beams of light and then passing them through a couple of lenses. And then the actual interference pattern itself actually looks like this guy right here. This is an example of what is called a Fabry-Perot interference pattern. And then right here at the center, this would be the bright fringe that we would see, for example, if the two light beams arrived back at that point at the same time. Okay, now back to the animation. Over here on the right-hand side, in this case, we are assuming that the Earth is moving with respect to the ether. And then you can see that the two beams of light do not arrive back at this point here at the same time. The blue light beam, which is traveling along the parallel arm, as it's called, of the interferometer, that is parallel with respect to the Earth's motion with respect to the ether. This then means that this light beam here in blue lags behind the red light beam, which is moving along the perpendicular arm, that is perpendicular to our motion with respect to the ether. And then therefore the two beams of light would arrive back at this point here out of phase with respect to each other. So instead of seeing a bright fringe at the center of the interference pattern, you would see, say, instead a dark fringe. Once again, this is basically the idea behind the Michelson-Morley experiment.